Hi there, welcome back here, guys. In this lecture we had off-topic lecture, I was just talking about the size of the result of Keccak 256 function, so this resulting hash of 32 bytes. In this lecture, we'll continue with additional explanation of the storages. We'll be talking about the storage of dynamic arrays. Okay, so let's stay here in our storage.sol. And I will reorder a little bit this here. Keccak 256, this should be next to the mapping, so that's how it's stored in the storage. Keccak 256 of the key and the slot. All right, and then we'll create here after the mappings dynamic array. So let's say we'll create the dynamic array of uints 256 or just a uints. All right, we'll call it, will be public. It should be array, of course. Public, we'll call it, let's say, to seize. Okay. Like this is dynamic array, and we will also push some items into this array. And the dynamic array is also taking the separate slot. This will be there for slot 2, and all these other slots will move. So this will be slot 2, this will be slot 3 now, this will be slot 4, slot 5, slot 6. Perfect. Okay, so our new array will push here some items. So in the constructor, I will write our array. Let's push their number, let's say 1, semicolon, push number 10, semicolon, push number 100. So we have 3 items in the array. Okay, these comments here you can remove. We don't need them. Okay, like this, or maybe leave this one. Maybe we'll use it. Okay. So now we need to save, we need to remigrate. So go ahead to terminal, you know what to do. Truffle migrate dash reset. And let's take a look what we are keeping at the storage slot number 2, where should be our dynamic array. As with the mappings, you have found out that in the mapping slot we are keeping nothing, but we need to use this Keccak hashing function to access the actual value of the mapping. With the dynamic arrays, it's a little bit different. When I will access the slot 2, so let's access it. Let's go here. Let's write here Truffle console. And let's go to our contracts. Let's click outside contract, storage contract. Let's get the address here. And let's access here web3 eth get storage at 0x. Oh, I don't need to 0x. I already have the 0x. My mistake. 0x and slot number 2. You will see here you have here 0x03, which is in the decimal 3. That's a 3 value. What we are keeping on the dynamic array slot is the size of the array. Our size of the array are 3 items. I pushed into the array 3 items, so the size of the array, the length of the array is 3. That's what we are keeping in this slot. But where we can find our values, our specific values of our array. Okay, they are stored a little bit differently, so I will write also comment for dynamic arrays how they are stored. Okay, again, you will need to use the Keccak function. It will be Keccak 256 of the slot plus index of the item plus index of the item Okay, I'll show you an example. So we know our array is the slot 2, so we need to run it through the Keccak 256 and the 2. First, it should be in a hexadecimal. So let's get here this sequence of 64 characters, which will represent 0x here. Let's count the number 65. I have one more, so it should be 64. I will just remove the number 0 here. I have 64. Perfect. And then 2, because that's a slot 2, right? So this is slot 2. Let's copy this value back to browser. Let's run it through Keccak. Make sure it's hex here selected. Hex is selected. Let's paste it here. That's our value. Let's copy it. And now we can simply access it. So since our index 0, since our array has an index 0, first item in the array will be at this slot here. Okay, so we don't need to do anything here. We just need to get this value. And we need to get here web3 eth get storage at and this value of the Keccak. Oops, I forgot 0x there. 0x should be there. Okay, I need to Oh, I need to traverse the entire string here now. Okay, and 0x. Okay, maybe do this. Okay, 0x. And you can see that's your first item in the array. It has a value 0x01, which is a 1. And that's what you can see here. We stored here value 1 and the first item in the array. Okay, so we use the KESAC 256 on the slot plus index of the item, which is a 0, which is basically just this part here because anything plus 0 is the same value. Okay. And now let's try the first item in the second item, which will be on the index of 1. So we should retrieve 10. Okay. Since we have this function of the KESAC 256, the resulting hash, let's transform it into the decimal number. Okay, let's go to hexadecimal to decimal, and let's get this value here and convert. So here is your decimal value. That's your decimal value. I can copy it somewhere next here. That's our decimal value of this result of KESAC 256. This value plus our first index of the item, the second item, so index 1 in the array. So this plus 1 would be this huge number, plus 1 is just let's add 1 in the end. So this will be this value here, 23 in the end. Okay, so now we just need to hash it. We need to transform it to the transform it into hexadecimal format. So I'll just open this on the second window here. I'll transform this number into hexadecimal because now it's a decimal 10-base system. So I'll go from a decimal to hexadecimal and I will transform this number. We have added plus 1 to the previous one. Convert, and this hexadecimal number will be the storage slot. Okay, so I will copy it. I'll go back to terminal. I will get here 0x, and you can see 0x0a. This is number 10. That's number 10 here. The second item. So now let's go for a third item in the array at the index of 0, right? This is the index 0 and the index 2, index 1, index 2. So now we have this original value of our KESAC 256. That was the original value we got back in the decimal format. Now this number plus 2 will be in the end 24. So we need to just get a hexadecimal representation of this decimal number. Okay, here convert this here, copy back here and get storage at 0x, and that is 0x64, which is from hexadecimal to decimal. That's number 100. Alright guys, so that's how your values are stored in the storage internally. I can remove these comments, we don't need them any longer. Now you should have a pretty good idea how this works. All right, let's keep it here this way. Any questions, ask in the Q&A, and we will continue in the next lecture with more of our storage, not of our storage, but more of our contract implementation. So guys, hope to see you in the next one.